now that we've dealt with systems for a while, let's talk about the matrix. Now, the matrix is not as interesting as it kind of shows or kind of says right here. All the matrix is a rectangular arrangement of rows and columns. Arrangement of numbers. Well, it doesn't have to be numbers, it can be objects. Let's call that objects. How about that? So let's call it objects. Usually numbers, but it doesn't have to be. So a matrix, say for example, to draw a matrix is, for the most part, you have brackets, right? And then from those brackets you have something in the, you have, now let's put numbers in there. 1, 2, 3, 4, right? Just a rectangular arrangement of rows and columns. Usually what happens is we name these matrices so that when we talk about them, we can just refer to their name as opposed to saying all those numbers in it. So usually we call them capital letters. So let's say that A is this matrix containing 1, 2, 3, 4. Now, let me show you where these numbers actually are. Well, I'll show you another matrix actually. In this matrix, you see, we'll call this A as well. Now, when you're looking at it, it's essential to know where the actual numbers are. Say for example that 5 right there. The 5 is in the first row, third column. Just like how this 0 is in the second row, first column. That's the way that we kind of classify it. So looking at it, you can see that this matrix has 2 rows, 3 columns. We call this a 2 by 3 matrix. It's a 2 by 3 matrix. So if this is a 2 by 3 matrix, then what are the dimensions of this matrix? Dimensions of this matrix is 2 by 2. So essentially, you want to always make sure you are going row by column. How many rows by how many columns there are. Let me give you one more, and I want to see if you're going to be able to get it. Let's say this matrix right here, B, I called it B, matrix B. What's the dimensions? In other words, what is the dimensions of this matrix right here? I'll give you a little second. Think what actually is the dimensions. If you said it's a 3 by 2, you would be correct. Remember, row by column. So let me slide over here to matrix C. What is the dimensions of this matrix? Again, if you said 4 by 3, you are absolutely right. Why? 4 rows, 3 columns. Cool. So understanding that's just the attributes of what a matrix is. So then once we understand what a matrix is, we can do matrix operations. The book gives you this about adding matrices, but there's letters in there and they're adding together. I know how much that doesn't make sense. So let's actually just go to an example. If I go to an example, I'm just going to give you numbers. Perform the indicated operation if possible. In part A, you could do this. So basically what you're going to do is every single element you are going to add to the number in its corresponding position. So say for example this is matrix A and this is matrix B, then in the corresponding positions you're just going to add those numbers up. Let me actually show you what I mean. So let me get a matrix there. Let me just make sure I'm rolling. Looks like I am. Let me get a matrix there, and with this matrix let's add the numbers together. So the first row, first column is in A is 3. I'm adding that to -1. The next number 0 and 4. So in In that second position in the first row is just 0 plus 4. The first position in the first position in the second row, -5. Add that to the first position in the second row in matrix B, plus 2. And then the last one should be what? -1 plus 0, because second row, second column, plus second row, second column. That's ultimately what you end up with in each position. So when you add those stuff together or simplify the matrix, the new matrix you end up with is 2, 4, -3, -1. That's how we added those matrices together. So I give you that, and same thing happens with subtraction. The same exact things happen with. If you think you get it, then why don't you pause the video, try this problem, and see what you come up with. See if you end up with the same thing I do. But I'll just keep going for the people that don't understand yet. So if I'm subtracting those together, remember I put my brackets, and now I'm subtracting. So first row, first column is 7 in this matrix right here, and then it's -2 in this matrix. So we're doing 7 minus -2. First row, second column, there's a 4, there's a 5, so you're doing 4 minus 5. And we can fill up the rest of this matrix with 0 minus 3, -2 minus 10, -1 minus -3, and 6 minus 1. So then all it is just doing the subtraction, and the matrix you should end up with is the matrix 9, -1, -3, -12, 2, 5. And just for kicks, understand that this right here is a 2 by 2 matrix. We're going to be doing most of our work with 2 by 2 matrices. And this one down here is a 3 by 2 matrix. So it's good to understand the dimensions. The reason why is because one thing you need to know is that the dimensions of the two matrices must be equal before adding or subtracting them. If they aren't, you can't add them or subtract them if the dimensions are not equal. Cool? Another operation we talk about is multiplication. Now, this is not the multiplying two matrices together. It's just multiplying your matrix by a specific number. We call that scalar multiplication. The number that you're multiplying the matrix by is what we consider the scalar. For example, let me give you this problem. I'll zoom out so you guys can see that. And let's deal with this problem. Say you're doing -2 times that matrix right there. All that's happening is you're taking this scalar right here. That's what we call a scalar. So I'll put it. That's what we call the scalar, the number we multiply by. So we're taking the scalar and we are distributing it to every number in the matrix. Every single one. And that's a lot of drawing right there. So let me get rid of that. And let's actually go over to what I'm talking about. -2, that's going to be -2 times 4. -2 times -1. -2 times 1. -2 times 0. -2 times 2. And -2 times 7. So once we do our math, then you know the new matrix is going to be -8, 2, -2, 0, -4, -14. So you can see how we do scalar multiplication and how we do adding matrices and subtracting matrices. What if I put it all together with this problem? First, so you're multiplying and you're adding. Again, if you want to try this on your own, why don't you pause the video, try the problem, and then come back for my explanation. So let's get to it. First off, order of operation tells us that multiplication is done before addition. So you should this part first. Once you do that part, then you can add, but we're doing multiplication first. So let's go through it. Now notice that I'm going to multiply that 4, distribute the 4 into the matrix. So I'll multiply every single number inside this matrix by 4. And we still have this matrix over here, but we're not doing anything yet. We're not adding until we multiply. So once all of that's done, now we can add those matrices together. So when I add all of those together, I should end up with negative 11, negative 24, 26, negative 5. So this stuff is relatively easy when you're just adding and subtracting them. Here's what we'll do. I want you to just take what was shown to you right now, and that's what we'll be working on. In class, we're going to be working on solving matrix equations. I'm not going to do that right now, but we'll do that in class. As of right now, that's all I got for you. Make sure you took notes on this. I hope this video made sense to you. That's all I got.